it up solving logs. Okay, just scoot it over. It's fine. It's fine. We are going to take everything we learned about logs into one lesson today. So let's remind ourselves, multiplication yields what again? Nicely done. What is a division yield again? Subtraction. Nicely done. And the power rule yields, what do you do with that power? In the front, what is that word? Yeah, it becomes a coefficient. Nicely done. Today we're going to do page 752. Numbers 9 through 16. Congratulations, this is the absolute last lesson of the year. Clap it up, clap it up, clap it up, clap it up. Tomorrow and Friday we have our round robin. Monday we're going to wrap up the round robin. Your final is Tuesday, Wednesday, and Thursday. So this is our last lesson of the year. Congratulations. All right, being that our last lesson of the year and I need you to focus on your final exam, our notes today are essentially going to be parts of the homework so that you are more concentrated on the final exam for the next 5 to 6 days, okay? Let's do number 9 together on tonight's homework. If you have 2 log base 3 of x minus log base 3 of 8 equaling log base 3 of x minus 2. I found it helpful at your age to highlight the arguments from the beginning. That way they stood out to me. And then I notice here that I'm going to start color coding that I have this minus sign and I have this coefficient right here. So I know that there's going to be some yielding of other operations. So this 2 is now a coefficient. So prior to being moved over here, where was it? Tell the person behind you where this was. Tell the person behind you where this 2 was. Lauren, where was this 2 before I pulled it down as a coefficient? Yeah, very good. It was an exponent. It was up here, okay? So we know that the next step would be log base 3 of x squared. Minus log base 3 of 8. And then now let's see if we can do something else with this minus sign. Kanoa, what is subtraction yield again? It was division. Very good. So that means my 2 arguments are now going to be divided by each other. So I have log base 3 of x squared over 8 equaling log base 3 of x minus 2. I notice that these log base 3's are already the same, and there's an equal sign here. So if the log base 3's are the same and there's an equal sign, then what do we know about the arguments? They also have to be the same. have to be the same because there's an equal sign in between them. So x squared over 8 equals x minus 2. I'm going to go ahead and get rid of this 8 by multiplying both sides by 8. This goes away, and I'm left with x squared equals 8x minus 16. And I have a quadratic here, so I'm going to just move everything to one side. So that's x squared minus 8x plus 16 equaling 0. And this is x minus 4 quantity squared. X minus 4 equals 0, so that means x has to equal 4. So what I have to do is I have to do what I did last night and make sure that my 4 creates a true statement. So I'll show you how to check in a second. I just want to make sure everybody wrote this down. Any questions on how we got 4? Sure? Dylan, are you good? So the way you would check your answer 4 is by plugging it back into the original equation, but instead of x, you're going to put 4. So you're going to put 2 log base 3 of 4 minus log base 3 of 8, and see if that equals log base 3 of 4 minus 2. You're just going to check and make sure that it's equal on both sides. You're going to move that 2 up, so you have log base 3 of 4 squared minus log base 3 of 8. That's log base 3 of 16 minus log base 3 of 8. That minus sign is going to yield division. So that's log base 3 of 16 over 8, which we know is 2. So log base 3 of 2. And we just want to know, does that equal, well, what's 4 minus 2? We do have that 4 minus 2 up there. So don't we have log base 3 of 2? So we know we're right. Yes, honey? I would say for your final exam, you don't want to risk it. You don't want to hope that you're right. Definitely plug it back in and check. Especially because you have 3 days to take the test. You're going to have plenty of time to check. Kyle, fight it, babe.
Are the classes 45 minutes?
It's a normal, yeah, it's a normal schedule.
So then what are we going to do for the lab?
Let me do that after the video, babe. Let me just make sure I get through this, okay? All right, let's do one more together, and I'm going to give you guys a doyo to try on your own. Log base 4 of x plus 3 plus the log base 4 of x equaling 1. Again, you should always highlight your arguments so that they stand out to you. Addition, again, yields multiplication. So you're going to multiply your two arguments here. So log base 4 of x times x plus 3. Now they're both in there. Make a little side note to yourself. Yields multiplication. Yes, honey?
So the summary works if it's
Exactly. Yes. And this equals 1. So we're going to do what we did yesterday. What did we do this for again? Those of us who didn't copy the homework, who actually did it. What did you do with this 4? Piggyback the 1, and then it equals the? Yeah. So 4 to the 1 equals x times x plus 3. Can you guys take it from there, please? And then we'll check our answers in 2 minutes. I do have a factoring quiz that had no name on it, so if you did not get yours back, you should come see me at lunch. Check your answers with your neighbor, please. All right, after you factor and solve, you should have gotten x equals -4 and 1. Raise your hand if that's what you got. Very good. So we have to test both of these now. And this goes to Gearson's point. The reason why you have to test this is because one of these actually doesn't work. I want you to pick one, either one, and guess which one you think won't work and try it for me. Pick either -4 or 1, please. Here, we're gonna go over both, but I just want you to pick one and go through it. How many of you guys plugged in 1? Did it work? I was still working on it?
Yeah.
Okay.
I got 1.
Does 1 work, yes or no?
Yeah.
Yeah, 1, when you plug it back in, it works fine. How many of you guys plugged in -4? Did it work? No. -4 does not work. -4 does not work. So that's why it's really important that you plug it in, because what we call -4 is what we call an extraneous solution. And those of you moving on to pre-calculus next year will be very well versed on extraneous solutions. Solutions that make mathematical sense, but does not make real world sense. Yes. Yeah, sure. So I'll show you why 1 works. Did you already do 1? Okay, so it's the -4 you're having problems with? Okay, sure. Let's plug in -4. So log base 4, -4 plus 3, plus log base 4 of -4 has to equal 1. So log base 4 of -4 plus 3, so log base 4 of -1. Agreed? Plus log base 4 of -4. So the problem with this is 4 to a power can never equal a negative 1. This is why it's extraneous. It's like it makes mathematical sense. Like if I were to take this, what does addition yield again? Multiply, right? So you'd have log base 4 of negative 1 times negative 4, which is 4. And then you would think that it would work. But right here, the error is right here. Log base 4. 4 to what power gives me negative 1? Nothing. How about this one? 4 to what power gives me negative 4? Nothing. Not even a negative number? No. What happens if you put a negative in exponent? What's 4 to the negative 1? That's 1/4. That's not negative 4. So the error is in the fallacy in the mathematics. That's why it's called extraneous. There's just no possibility here. Let me make sure you guys are okay with that. You guys okay now? Let's try a doyo, okay? Try this one on your own. It's going to be number 11 from tonight's homework, which is log base. There's a log base what if I don't put a number there? 10. Very good. So log of 2x squared plus 3 plus log of 2 equals log of 10x. Alright, so addition yields multiplication. So that's going to be 2 times 2x squared plus 3 equaling the log of base 10x. These logs are the same, so you could drop them and focus on just the arguments. So 2 times 2x squared plus 3 equaling 10x. I'm going to go ahead and divide both sides by 2 to get rid of this 2. You could have distributed the 2, and we would have gotten the same answer at the very end. So 2x squared plus 3 is equal to 10x divided by 2, which is 5x. Bring that minus 5x over and factor, and you get 3 halves and 1. Let's try another one together, number 12. Log base 2 of x plus log base 2 of x minus 6 equaling 4. So I have these two arguments, this addition sign in the middle. That means it's going to yield multiplication. So that's log base 2 of x times x minus 6 equaling 4. We're going to do what we did last night. We're going to piggyback this 2 over the 4 equaling that argument. So that's 2 to the 4th equaling x squared minus 6x. 2 to the 4th is 16 equals x squared minus 6x. 0 equals x squared minus 6x minus 16. And all we gotta do is factor that. That's a minus 8 and a plus 2. So my two answers are x equals 8 and x equals negative 2. And I'm always very weary about negative answers because I just realized I can't find a power that's going to get me to a negative answer. So if I plug in this negative 2 here, right here, help me out. This is going to say log base 2 of negative 2. That's what that says. That means 2 to an exponent gives me negative 2. 2 to an exponent gives me negative 2. Is that possible? No. Even if I put a negative up there? What's 2 to negative 1? That's 1/2. That's not going to get you negative 2. There is nothing you can put up here that's going to make this work. So which one of these is actually extraneous? Negative 2. The only answer is 8. That's it. Shall I do one more with you, or would you like a doya? Doya? Alright, so number 13, try this one on your own. See how far you can get, and then if you get stuck, ask your neighbor or call me over. I'm happy to help. 2 log base 5 of x minus log base 5 of 4 equals log base 5 of 8 minus